Compound interest is the other way to do lump sum savings. And compound interest is an exponential equation. And the compound interest actually comes in two different forms. It comes in terms of compounding periods, and there's a formula for this particular one. And then we also have compounding continuously, which has a different formula. But you'll notice that they both have an exponent attached to them, and so that's why this is an exponential equation. And it's just modified to the original one. Again, there is an initial value, so that's our p. Then we had 1 plus or minus the relative constant rate, again as a decimal. Again, since we're adding money, we're saving our money, this is going to be plus. And then you have R, which is that interest rate, that percentage, which would have been the relative constant rate, but we have to divide it now by N, and N is the number of times compounded per year. And so we have different types of compounding, and it depends on just, you ask the question of how many times per year does the word indicate. So if we have annual, well, annual means just one time per year. If it was monthly, monthly happens 12 times per year. If it's daily, in general, we have 365 days in 1 year. If it is bi-weekly, bi-weekly is the same thing as getting paid every 2 weeks. There's 26 of those. If we have semi-monthly, that's getting paid, say, the 1st and the 15th, or the 15th and the 30th. There are 24 of those. So depending on the word, that tells you what type of compounding period it is, and that tells you how many times per year. So that's what this N represents, is how many times per year does the word represent. So that's the number that goes in for the N. And then the Y just represents that input letter. So in terms of the number of years that we're compounding for, the number of years we're saving our money for. When it's continuously, this 1 plus Rn kind of goes away, and we just have this E. And E is just an irrational number. And it's just like pi. Pi is an irrational number, so is E. So an irrational number is a decimal number that never repeats and never stops, never terminates. So E is just a button on your calculator, or you can type the letter E in Desmos, and it understands that that's what you're referring to. So we'll do those so that we can see how to enter these into the calculator, how to enter them into Desmos. All right, so we're going to take that same, so if you recall from our simple interest problem, we had $250 for 4.5% simple interest, and we ended up after 5 years with $306.25. This time we're going to take that same $250 for 5 years, but we're going to compound it annually. Okay, so this is telling us now that we're using the compound interest formula, and we're using the compounding periods because it's telling us annually, monthly, and then here it changes to continuously, and so continuously is a different formula. That's the other formula. So we're going to find out how much money we're going to have in the bank, and then how much interest was earned. And so we look at our formula, our equation, and so we have A equals, and P, so the initial amount of $250. And then we have this 1 plus, now the interest rate is 4.5%, so 0.045 divided by, now annually is 1, so divided by 1. And then we're going to raise this to the parentheses 1, so that same 1, plus, times however many years we're doing this for. So that's that time, ny is 1 times, in this case, 5. Right? So I'm going to put this in Desmos just like I see it. So I'm first going to show you Desmos. So we have $250, and then we have parentheses. So let me get so we have parentheses, and then 1 plus, and then I'm going to type in the percent, 0.045, so that's the percent as a decimal, divided by, notice that when I hit the divide key, I get the fraction bar, 1. Now I'm going to go outside of my, my parenthesis, the A to the B, so that exponent key, parentheses, 1 times my 5 years. And so I end up with $311.55. So $311.55. Now, if you have a graphing calculator, you don't necessarily, depending on the graphing calculator, you don't necessarily have to have those parentheses, but it's always just a good practice to go ahead and use the parentheses, and then you don't have to worry about making a mistake. All right, so in our simple interest, when we figured out what our interest was, we could just multiply the amount of interest times, so we could take this amount of interest made each year times 12. Well, we don't have that in compound interest because, again, it's growing exponentially. So the only way we can figure out the amount of interest earned is to take $311.55 minus our $250, that was our original amount, and come up with that answer to give us how much interest was earned. So we earned $61.55 in interest. All right, if we look at the next one, so we have monthly compounding, so the same equation. So A equals $250 times 1 plus 0.045, but this time it's monthly, and there are 12 months in a year, so the n is 12, parentheses, and then raised to the 12 times 5. So again, this 12 is because we're raising it, or we're doing compounding it monthly. So going back to Desmos, I can just change my 1s to 12s, and I have a new dollar amount of $312.95. And again, the amount of interest earned is going to be $312.95 minus our $250. So this time we're earning $62.95, so a little bit more, because the more and more times you compound, the more money we're making. Now, compounding continuously, different formula, right? So now we're using the compounding continuously formula. So it's PE raised to the RT. So A equals 250. E, and then our interest rate now goes on top, 0.045 times the amount of years, so 5 years. Okay, so this time I'll show you both in Desmos and in a graphing calculator. So in Desmos, we have 250, and I'm going to go to my letters. So I'll go back to my letters, and I'm going to type just the letter E, and it automatically knows. Notice that it gave me a dollar amount right away, so it knows. But now I need to raise it to the, I'll use parentheses, 0.045 times our 5 years, and we end up with $313.08. So we have $318 or $313.08. Now in a graphing calculator, you will see that right here in the LN button, which is next to the 4 button, you'll see this little tiny e to the x. That means you're going to have to use the second key and then the LN key. So we have $250, and then I'm going to hit the second and the LN button, so the natural log button, and notice that it automatically gives me a raised 2 in our, so we just need to type in 0.045 times 5. Okay, so this is how this would look. Again, the LN button is the one, so the second key, and LN gives us, and then we end up with our $313.08.